Hello students, today we are going to learn about properties, that is combustion, addition, substitution. Some important carbon compounds like ethanol, properties of ethanol, uses of ethanol. Number 2, ethanoic acid, uses of ethanoic acid, properties of ethanoic acid, esterification, saponification, how soaps and detergents work, that is missile forming. Burning any substance, in this case carbon compound, in the presence of oxygen is called combustion. Combustion is of two types, complete combustion and incomplete combustion. Burning in the presence of oxygen, the sufficient supply of oxygen, we call it as complete combustion, where insufficient supply of oxygen or limited or very limited supply of oxygen, we call it as incomplete combustion. In case of complete combustion, when sufficient air or oxygen is provided, we get carbon dioxide as a product and heat and light as a byproduct. Incomplete combustion and combustion of unsaturated hydrocarbon gives out soot, that is black color smoke. Incomplete combustion gives out carbon monoxide or carbon as a product. Example you can take as kerosene, petrol, diesel, etc. Addition reaction. Unsaturated hydrocarbons participate with the help of a catalyst, nickel catalyst, with hydrogen weakly bonded to it. Example, hydrogenation of vegetable oils, alkenes and alkynes are used. You can see it on the screen. Substitution reaction. This reaction occurs in the presence of sunlight. This reaction is very fast, where hydrogen of the methane is replaced by the chlorine and the end product is carbon tetrachloride. Oxidation. Addition of oxygen to a carbon compound, that is called oxidation. It is mainly done with the help of catalyst. The catalyst over here is K2Cr2O7, that is potassium chromate acidified, or alkaline potassium permanganate. These are called as oxidizing agents. Let's discuss about ethanol. Ethanol is liquid at room temperature, commonly called as alcohol, used in medicine, tonics and soluble in water. Alcohol or ethanol reacts with sodium to produce sodium ethoxide and hydrogen gas. You can see it on the screen. Ethanol in the presence of hot concentrated sulfuric acid, that is at 443 Kelvin, dehydrates, that is removes water and produces ethene. Let's discuss about ethanoic acid. Ethanoic acid, commonly called as acetic acid, which we use acetic acid that is 5 to 8% dissolved in water as vinegar. Acetic acid freezes at 16 degrees, hence we call it as glacial acetic acid. It is used in industries, manufacture of esters. So what are esters? Esters are nothing but alcohol reacting with acid, we call it as esters. So looking on the screen, we can see that ethanoic acid and ethanol are reacting together to form ethyl ethanoate, that is nothing but ester, by removal of water. Now after removal of water, we call this one as ester. So this is nothing but ester. Now what is the ester? Esters are sweet smelling compounds. They are used in making perfumes and flavoring agents. Esters on treating with alkali, that is NaOH, produces sodium salt of carboxylic acid. This method is used for preparation of soaps, and this process is called as saponification. Formula of soap is C17H35COONA. You can see the long chain on the screen, which is nothing but the product of saponification. You can see a hydrophobic and a hydrophilic end, that is hydrophilic end is COONA, which is attached to the water, so hence we call it as hydrophilic end. Hydrophobic end, which does not attach to water, it's attached to a non-watery substance or greasy substance, we call them as hydrophobic end. Now let's discuss about the working of the soap. So the above carboxylic acid chain has two ends. One end with a Na is called hydrophilic, the other end with CH3 group is called as hydrophobic. Hydrophilic means attaches to water, hydrophobic means does not attach to the water. Hydrophobic end reacts with a stain on the cloth, and hydrophilic end will react with the water. Now the many soap molecules form a cluster around the stain, and they are called as micelle. These micelles do not precipitate due to the ion-ion repulsion and flow out with the water. Because of the micelle formation, the soap solution appears cloudy. Thank you all for watching. Have a nice day.